Hi, Nancy Michael here again. I hope you enjoyed our first session of Neuroscience and Your Behavior, and I'm excited to welcome you back to our second session. We have two campus experts joining us, Dr. Kristen Valentino and Dr. Elizabeth Archie. Their research focuses on ways in which environment influences brain function, behavior, and long-term health. To prepare us for their session, it's important to revisit things that we've learned previously. We've talked about neurons and glial cells. We've talked about how brain development is influenced by processes like proliferation and pruning, and how the brain comes together in these structure-function relationships. Most importantly, the brain is a situated organ, that this external environment and the internal environment and how these two places communicate with each other create an emergent property of brain function. It's not that we're just a bunch of neurons and glial cells in a bucket, but we're organized, our brains are organized in a very particular way down to the microstructure of those cells that influences brain function and behavior. Doctors Valentino and Archie will likely spend some time discussing critical or sensitive periods of development. In the process of brain development, there are certain times where the brain is particularly sensitive to what's called a domain-specific stimuli for a limited time. So domain-specific stimuli would be something like visual input, auditory input, taste, touch, so that the nervous system is expecting a certain level of experience. And so during this critical or sensitive period of development, the brain looks for this, right? And it's during this critical period of development or sensitive period where that environmental experience produces profound change in the system during that window. So exposure to that same stimuli, vision, smell, taste, touch, either before or after the sensitive window is either ineffective at inducing organizational change in the context of structure-function relationships, or more often, the ability to induce such change is markedly blunted. So this is a lot of words, but basically it's saying that our brain is sensitive during development. At different times, it's looking for different things from the environment and expecting those things from the environment. But our actual experience, regardless of the expectation, our actual experience with those domain-specific stimuli ends up determining the baseline neural architecture from which we use in later stages of development. So it would make sense then, if there are critical or sensitive periods of development that have such a profound impact on development, there are also the converse, or the expectation of that, is that there are what are called species expectant experiences, right? And so you can think about this. The nervous system, based on these critical periods of development, the nervous system, or this human species, expects certain input from its environment during particular periods of development. And so let's think about this. What can a baby do? Not a whole lot, right? Babies can cry. They're not really good at even regulating their body temperature when they first arrive, right? They're completely dependent upon the outside world, right? So one of the most critical expectations of the developing nervous system is actually an attachment figure, because in the absence of this attachment figure, there's no access to food, there's no access to nutrients, there's no access to temperature regulation, right? We can't clean ourselves. And through this attachment figure, right, we also expect this environmental complexity. We would call this enrichment now, but if you think about kind of the long game of human history, the majority of human history was spent outside exploring the environment. We expect language tutor, language complexity, auditory complexity, and language exchanges. The literature talks a lot, and social complex environments. So kind of in all of this, that we can capture a lot of these behaviors in what are called serve and return relationships. And I am pretty confident that our faculty guests will expand more on the meaning of those. In the context of brain development and in the context of longer term health, then the question becomes, for what synapses, right, from a brain architecture standpoint, from a neural proliferation and cellular complexity standpoint, from a pruning standpoint, For what brain connections or synapses and therefore skills do all of these early exchanges provide the neural framework for, right? If we don't have, right, we're constantly engaging with our environment. And so these early experiences become very, very critical in building foundational neural architecture for tiny humans. This foundational neural architecture via attachment. So attachment is not just about the loving and the cuddling, but it's about the expectant mentorship that tinier humans have to receive from bigger humans, right? Humans do this thing called alloparenting, where we care for not just our own children, but for the children of others. So this early attachment and these early exchanges with our environment via our bigger person mentor informs the way that informs the neural architecture that's established foundationally in our brain, and that informs the way that we engage in future behaviors and in future relationships. The level to which it informs our physiology, our hormonal status, and our brain function is dependent upon the intimacy of the attachment. But this, let's sit with this just for a little bit, right? Because this is mind-blowing, I think sometimes. It was for me to know that my physiology, my heart rate, my hormonal status actually syncs up with people that I'm close to, right? So the power and position that a caregiver has over the regulatory development and capacity of a younger child's not only neurobiological system, but biological hormonal system at large. So it's not only attachment that moderates these things, but attachment provides a really foundational platform from which we learn, right? We learn, there's a principle in neuroscience called Hebbian plasticity, right? And the catchphrase for this is neurons that fire together, wire together. So these early exchanges with our environment really provide a very, very strong potentiating stimulus across sensory domains, right? It's not just vision, it's not just sense, it's not just touch. That the way that we engage with our environment at large provides, and regularly provides, the information that our nervous system then looks to determine how we're going to proliferate, how we're going to prune back. In the context of children and brain development, children have a neurobiological need to attach. We established that infants have no capacity to care for themselves. And human development is very, very protracted. So we are dependent upon care for quite some time before we can become independent from our primary caretakers. So children have a neurobiological need to attach. They have no choice. In other words, human infants become to whomever their primary caretaker is, no matter what that experience. And we all would like to believe that all kids are raised with ample resources and ample relationships and ample love, but we know that that's not the case. And so we all have stressors in our lives, but some children grow up with extraordinary stressors. So some basics about how the stress response works. We have a stressor, right? Oh my gosh, there's a scorpion. Now, this could be exams for some students. This could be an individual or a situation, but whatever the stressor is, again, based on the sensory environment and the previous learning about a stressor, there's a series of neural circuits that are activated within the brain, and ultimately it ends up in the activation of the stress response, right? We've all heard about the stress response. We commonly talk about it as the fight or flight response. In the literature, we talk about it as the HPA axis, or the hypothalamic pituitary adrenal axis. But regardless, sensory stimulus coming in, bombard your senses. You have a stressor and activates a series of responses that starts actually a little bit above the level of the hypothalamus in the brain. It's part of the brain called the amygdala that sends that initial distress signal based on previous learning. Series of cascades change activity in the brain. Part of the stress response inhibits the hippocampus, which is the brain's primary site for learning and memory. Then we have a series of cascades that communicate from the hypothalamus to a part of the endocrine system called the anterior pituitary. The anterior pituitary communicates with the adrenal cortex in the kidney and stimulates the release of cortisol, We've all probably heard about cortisol too. It gets a pretty bad rap in public, in like pop culture literature. Cortisol is pretty essential actually for normal biological function. And in the stress response, what happens is it serves as a negative feedback, so that once cortisol takes time, right? It's released as an endocrine factor into the blood. It takes some time to circle back up into the brain. When it reaches the brain, it serves as a negative feedback signal to turn the stress response off. Unfortunately, in cases of prolonged chronic stress, and this is where cortisol gets a bad rap, that the stressor, the sensory stimuli triggering the stress response, is persistently present. So this negative feedback loop becomes broken. And what we end up doing is just increasing the levels of cortisol in the blood and in the brain, so that we're chronically bathing the entire physiological system in not only cortisol, but other stress hormones like epinephrine, norepinephrine, commonly referred to as adrenaline and noradrenaline. Right? So it's this persistent activation that ends up causing the physiological damage. And so when we put this in the context of species expectant experiences, what do developing humans expect? This attachment figure really does become kind of the gateway to everything else. And so the questions that we'll explore in much greater detail with Drs. Valentino and Dr. Archie is what happens to a neurobiological and biological system when the demand on individual agency exceeds the supply of resources, right? Because when our demands on agency begin to exceed our resources that we have to meet those demands, right, that is when we can become stressed. And so it is that chronic stressor, or the balance between agency and resources, accessible resources, that becomes a really critical factor in determining the actual perceived stress dose on a developing system. So this is where we're going to spend a lot of our time, data related to this broad question. So looking forward to seeing you. I hope that you enjoy. I hope that you submitted some questions at the end of the last session. We'll work really hard to integrate and incorporate a lot of the questions that were submitted. So thanks for staying engaged, and we'll keep the conversation going.